walk you through how to use unstructured as a way to ingest your PDF complex documents much more easily. Unstructured is both a platform and an API that encapsulate a lot of the capabilities and that you're looking for to pre-process complex PDFs. And it solves a lot of the issues around positioning. When you're loading a complex PDF that has tables and images, and the order of things on the page matters for your natural language understanding. Plus, you need a high resolution, high quality ability to ingest a document with fewer errors. It's a really good choice. They have some great models that they make use of and services, plus the flexibility to build a pipeline of services such as OpenAI for the embedded encoding or Hugging Face. So I'll walk you through how all of this comes together and show you a repository that I built that has all of these capabilities in a soup to nuts RAG prep or ingest application. So first of all, what we will do is create a login with unstructured. It's free for up to 1,000 pages, I think, a day. So I'll sign in to show you what this looks like. Yep. Okay. So now once I'm logged in the free account, you go to APIs. You generate a new key. Give it a name, friendly name for your billing tracking purposes, and you'll get an API key. And from here, what's really cool is you can copy the key, or you can copy to Python, which will give you a little snippet of code to have your first run at this. So in Cursor, I created a new project. We'll just do a quick test. So first thing, I'm gonna go into my terminal and create an environment for this project. And I'll create this file and paste what I got from unstructured. And you can see they've already put in the API key and gave me a sample call. But that's fine, because we're going to be more advanced, and don't bother copying this key because it's going to be removed right after this demo. Alright, so I now have my environment and interpreter set up properly. I can delete this demo code because first I want to show you how this thing works and where to find the documentation. So in unstructured, if you go, I think, into help and documentation, over here, they've organized it in a pretty interesting way. One of the ways that I learned this is I jumped right to the example code, and these are Python notebooks. So for instance, here's one, how to implement RAG with PDFs, LangChain, and Llama. So they are doing the pre-processing and ingest, and then they're showing a full end-to-end RAG solution. And I'll show you a quick walkthrough of what that one looks like. So they're doing the installation of the dependencies, putting in your keys, and then they're showing you how to build a pipeline. So in a pipeline, what you're able to do is you can define how to process the PDF, how to split it. So this is the partitioning sections. Here they're saying split it by page, and concurrency means that it'll spawn 15 processes in parallel, which can affect the speed. But if you do not have a multiprocessor, be careful. In my server, I've upgraded my service. So, and I installed like this, click install htop, and now I can look at my memory, and you can see that I have 4 processors, 0, 1, 2, 3, and 8 gigs of mem. That gives me a nice level of performance. Okay, so going back, then they defined a function to load the JSONs. This short snippet will read the PDFs, and it will process them and save the output to a local folder, and that output is a JSON, and I'll show you what that JSON looks like as we go through this. So then this loads that JSON, and it creates a link to a embedding model, and then it will, and that embedding model, by the way, they picked is the BAII. So if you go to Hugging Face and you want to know what that model is, just search for that model, and it shows you that this is a model that supports, let's see, usage. So this is a model that supports several languages, English, Chinese, multilingual, etc. Anyway, after that, they quantize the model, and then they set up a RAG chain for a question and answer, and they're recommending to use this format. So here's the prompt. Start header ID user, that's the user prompt. You're an assistant for answering questions about IPM. You're given the expected parts of a log document and a question. Provide a conversational answer. If you don't know the answer, say I don't know, to make up an answer, etc. And then they send it a question: what is considered the cultural control in IPM? And it responds. So you could modify this if you're doing a project for the consumer product company. Then you could ask what is, you change the prompt, and you're an expert on a consumer product pool cleaning device, and etc. So now that you can see how this, how I go through the code, and I looked at this code and I tried to understand how it works. Looking at their API documentation, you can see step by step how do you process individual files using the unstructured API. And there are essentially two different parts to their offering. If you look at, they have a platform. The platform allows you to do some of the advanced processing that you will be able to do programmatically, and that's a paid service. But everything underneath it can be done using the API only, and that's what we're going to be looking at. So processing an individual file can be done using the unstructured Python SDK, JavaScript. They also have an open source Python library that you can essentially download and develop yourself, but I wouldn't recommend it, and making a post request. So let's say using the Python SDK, because when you do a pip install to these dependencies, then that's how you're interacting with it. And from here, they'll show you how to make a call. So if you're processing a file and you want just the basic way to set it up, this is how you do it. You create a client and you have a file, and then you build a partition request. And in that partition request, these are the different parameters. And then they show you how to do page splitting. In order to speed up the processing of large files, you can split them by page, and then they show you the different parameters. There's actually a really nice shortcut how to do this. And I think if you look, let's see, there is a tool online that allows you to generate the codes, and I'll find that link and talk about it in a second. So let's jump to the code in the repository that I've created, and that is PDF unstructured. So I make use of unstructured in order to show an end-to-end RAG application, and this is the link which you can get from here, right? This is the name of the I'll just copy this, the URL of the Git, and if you don't have Git installed, then install Git. And let's just exit and re-enter the prompt so we are using the environment. Now I can say I'm using the environment, and git clone and that link. Sorry, I put in that unnecessary backslash. Okay, so that creates a new folder. I can cd into that folder. This is where the app has been installed, and you can see now the folder with all the files here. I created 3 programs: a ingest staging, and then a image summarize, which enhances images that are found and uses OpenAI in order to prompt it and enhance them, and a conversion to Markdown that converts the JSON output files with the enrichment to Markdown that you can view, humanly viewable. So let's talk about the ingest. The ingest leverages 3 different files here. This is where the actual ingest occurs. This is the bounding box drawing on the images. I have added that so that you can diagnose what has been detected by unstructured, and the config file. And this is the first place I want us to look at. If you look at, at the config itself, there is a file called config.ini.template, and what you'll have to do is to rename this to config.ini, and this is where you're going to put your unstructured API key. This is the URL, you don't need to change this, and this is where you're going to put your open API key. So all of the 3 programs are going to use the same config file. Where is the data going to sit? So relative to where the scripts are, I'm going to create a folder called data. And in this folder, I'm going to get a couple of files that we're going to work with. So let's go into data, and let's create a input folder, right? Because I am saying that our input is going to be a subfolder of data. And I'm going to get a couple of files that we can use. So let's see, I think here, I found a pool cleaning PDF. Let's get this file. And let's get a 10K form for Cognizant. Here we go. This is the file. Let's get that. Alright, so if we look now at the data folder, we have these 2 documents. I can put them in the right folder. Let's put them into input. Okay. So now the way that ingest will work is let's look at how the main program is, because this is pretty simple to understand. First of all, it will look at the input directory and will identify what are the files. So there are 2 files that it will find, and it will load up the save bbox setting from the config. So if you look here under PDF processing, this indicates that the bounding box images should be created for the files, and this says that this is a setting that indicates that we want to have the JSON output, which we will always want. And this means that we're going to see progress on the screen. So let's look further. After it loads the settings and it's loaded the list of files, it will iterate through each of the files, and it will set up a output folder. If it doesn't exist, then it will create the output JSON from the pre-processing, the ingest. And if a JSON already exists, then it will ask if you want to reprocess it, and then it has a list of files that it's ready to process, and it will start ingesting. And this is the ingest PDFs. So this is the core of everything that we're building here, and that is the pipeline. So first I load a couple of settings from the configuration from our settings file, and for now I've disabled the use of an embedder because I don't want to spend the cost of embedding these large documents unless I'm going to actually use it while I'm experimenting. So if you're going to want to add embedding, you just change this to true. And this is the pipeline that sets up the ingest with unstructured. The parameters here, for instance, are where is the input coming from, and do you want to partition? The partition is very key here. Strategy, high res is for a more expensive in terms of how it consumes your credits, even your free credits. It's the right strategy for a complex PDF, one that has tables and figures. And if you look at the documentation, there is a question here around choosing a high-res model. Actually, there are some interesting articles here also about chunking and embedding, but in the overview they talk about some of these options. So let's go back. The API key from unstructured, the URL, this is all coming from the settings. This means that if there are images found, that they're going to be extracted and they're going to be embedded in the payload, which means JSON output. Instead of having 100 potentially JPEG files, which is an option, you can save them to disk, the individual images and icons and so on that are found in a document, but instead it's going to be part of the output in the JSON. And then I'm also asking it to provide coordinates, which are the XY positions of where images are found. And I want it to create images of or to do an extraction of image blocks for both images and tables. So although the tables will be converted to text, you will also have a graphical representation snapshot of tables, which you can refer to if someone is looking for a source reference when you're finding materials in the document search. All right, so that is really the core. So next up, let's give this a try. All right, so I'm going to go and back to the main folder, and we're going to try to run, and I'm warning you that there are going to be some dependencies that are missing. So what I'm going to do is pip install requirements, and that should start the installation for all the dependencies that are listed in my requirements file. And I'll come back once these are installed. Sorry, did I hit Python? All right. So, assuming all the libraries installed properly, you're going to start to see stuff happening, and you're going to see an output folder get generated, and it's going to generate a JSON output. And because we also asked to save bbox images, bounding box images, it'll draw using the coordinates that were found for each image detected and each partition in the document. It will give you a visual representation of what got stored. So I'll start there, since we are looking at the progress of the partition. I'll show you what goes into the output JSON, and then we can go further. All right, at some point through the through the process, and this cognizant document was really large, so it took longer to process. You're going to start to see two things. You see the JSON outputs for the two files, input files, and you're going to see it start to build up these image files. I'll widen this so you can see that these are individual JPEGs. So let's look at, I'll turn off the sidebar. Let's look at, for instance, the Dynamo. So what is in the Dynamo? Remember, this is what the file looks like. Let's shrink this a bit. It's a 12-page document, and it has all of these complex layouts, these boxes with text and tables, etc. And what does the output look like? This is the JSON output. So I'm going to turn off line wrapping. And each element, these are called elements. So this element starts here and ends over here. Each of these elements has the following. It has a description of what type of element it is, and an ID, a unique ID. If it was a text block, it would have the text here. Then inside metadata are the coordinates. So this image that was found, these are the coordinates, top left XY and bottom right XY. And tells you what is the pixel space where these coordinates are specifying. So this looks like it's, you know, top left corner of the page. And then it has what page was it found on, and it has an image base 64. This is the actual image itself encoded. Remember I said that we're not storing the images externally, the images on the page, we're storing them within the output. That's different from these images. These are images of the actual pages. So if I look at, I'm going to wait for all of this complete so we can look at the Dynamo output images. And then we have some additional information about the image. So these are sample images. If I go scroll down a little more, here's a title that was found. And the title is Pool Blaster, and again, it gives you the coordinates. And a narrative text. It found a small text, and I'm gonna scroll a little further, look for something interesting. Here's a narrative text that was found. It's this probably part of a bullet list of items, and it has the coordinates. And this one was found on page 2. So these coordinates are used by this code to give you an annotation of what the document looks like. It's starting to load up Dynamo, so I'll show you. Remember that the PDF looked as such. This is the PDF. And so let's load this up here on this one page. And then let's look at the annotated to the side. So it shows you what the detection algorithm looked like, and this gives you a legend. So you can see title is pink and image list item, etc. And that is, how do you zoom out here? There you go. So now you can see which images are being detected, which blocks, areas are being detected and read by the algorithm. Again, this is merely a visual representation of what is in the JSON. The JSON is really the only thing that matters here. And the one thing I want you to notice is that in the case of an image such as, let's say this one, this big blue thing, the only thing that you will have that's meaningful at this point is the actual image itself, which is this image base 64. What the next thing that we're going to do is we're going to look through each of these images and add the description. So let's close the PDF and walk you through how this works. What we're doing here is we're essentially we're going to reopen the JSONs. So this short application merely looks at the same configuration file, iterates through all the JSON output files in the output folder, and for each one of them, it opens the JSON, looks through all of the elements, and when it finds an element of type image, it will attempt to create a summary for it. And the way that I did it is I have a prompt here, Let's do a line break so you can read it. You're an image summarizing agent. I'll be giving you an image and you'll provide a summary describing the image, starting with an image or an illustration or a diagram or a logo or a symbol. And if it contains a part, you'll try to identify the part. And if it shows an action, such as a person cleaning a pool or a woman holding a pool cleaning a product, you can call those out. If it is a symbol, just give the symbol a meaningful name, such as a warning symbol or attention. All right, so let's run this. Let's see what this looks like. And all it does, it'll read the 2 JSON files that were created earlier by the ingest preprocessing and add these descriptions. The way it will add them, it will send it out to OpenAI using GPT-4o model, and then it will add a new value pair called LLM summary. So let's do that. Okay, so let's run this. And now it gives you, I'm using my keyboard, it gives you 2 files and it asks which one do I want to enrich. So I'm gonna enrich the Dynamo one. And again, what this will do is it'll look for any type of element whose type is image, and it will send the image 64 with a prompt query to OpenAI to enrich it and summarize it. So, oops, let's undo that and let's hit enter here. And now it'll start to summarize the images. You can see the progress because this will update the JSON file live, and you can see that at the end of every image it adds a new attribute, LLM summary. So an image of a smooth blue gradient background positioning from a light, and here is a logo, and here is a narrative text doesn't get modified. Let's look for the next image. I'll just search for an image. Image of a clear blue sky, etc. So this is a little hard to navigate. We have a graphic representation of how the page assembly works, but the next step in understanding what was found is to take the JSON output and convert it into a Markdown, and that's what step 3 does. So step 3 will take the JSON and it will create a Markdown file. So let's run this and see what the output looks like. Keep on doing that. I don't know why. All right, run step 3. Which one? Let's process the same Dynamo because that's the one that has the enrichment in it. That's it. That was quick. So let's look at the Markdown that it created. Turn off line wrapping, and now you can see that it adds the LLM summary into the Markdown. So if you look at the source for this, it's a pretty simple program. It iterates, it creates these, if it's a title, then it puts the title with a hash because that's in Markdown. Hash precedes a title. The interesting thing is how we add the annotation for the images. So if it's a element of type image, then it will load the image. It detects whether it's a JPEG or PNG, and then it will create a mini table that has the image. So this is the entire contents of the image. It is almost like a HTML embed. So this will display the image in a 1-column table, and then the next row it will have an emphasized list of the summary. The summary is from the LLM summary tags for that element. So this is a very clean output, but you say hard for me to read it, and I say install a Markdown extension, and then you can do a preview. And here's what it looks like. So I'm gonna close the source file because we want to just view the human-friendly version. And do I want to save this? I don't think so. Alright, so here's what it looks like. Yep, this is a blue gradient and this is a logo. And here are some safety instructions and some warnings. And all of these icons, a symbol of a BC mark. Here's a table. Here is a symbol crossed out trash can bin, often used to indicate disposal restrictions or guidelines. Pretty neat. Here are some images, an image showing a hand adjusting or holding the lever of the pool valve filter. The valve has a circular dial, various settings marked on it. And you can change the prompt if you are seeing that you need some different or better descriptions, modify it to your use case. But that's about it.